name is Baron. I work for a company called Firstmode up in Seattle. And
hello, my name is Jesse Benford. I'm a Team Center architect with Applied CAX.
And today we'll talk about how Firstmode is leveraging Siemens products for a better tomorrow. It's a story about how we implemented the Siemens Team Center PLM as well as NX. Part of our agenda, we'll do a bit of introduction for Firstmode and Applied CAX, go over what our objectives were for Team Center and how we were implementing PLM, then how it went, the whole process, and how it went for us, and kind of lessons learned, and then kind of what we're looking to do in the future as we build upon our first implementation of Team Center. So a bit about Firstmode. We are a global carbon reduction company that's focused on heavy industry. So this is a picture here of our proof of concept vehicle that we did a retrofit on for Anglo-American mining company. And our goal is to decarbonize haulage, where in order to hit sustainability and greenhouse gas emissions standards, you really need to decarbonize not just the truck or the vehicle. You need to decarbonize the entire system around it. Not just the truck, but refueling, maintenance, and so on. And you need to do all of that without missing, in this case, a ton. You can't upset the system because unless there's a minimal impact to the way the company is currently working, it's not really it's not an incentive for the business to make the change. And Firstmode has done just that. We've developed an end-to-end product and services that replace diesel. So not just the truck, the power system that goes into it, but how it gets the fuel, how the fuel gets produced, hydrogen gets produced on site or delivered to the site, and then put into the truck, maintained and run and optimized for whatever mine that it's going into. And you can see here the different systems, so including on-site support, transport services, and how the truck will get into the mine control system, or I forget the term they use for it. It's the software that they have that optimizes where the trucks are, where they go, when they get serviced, and so on. And we worked quickly to do this. It was took about 18 months to go from a concept design, figuring out how much hydrogen do we actually need, and the first principles of the, how much energy do we actually need to go up a hill? How do we need to dump out all of the tons of material that's going to be in the bucket of the truck? And once we figured out modeling for it, simulating it at a very high level, we moved on to prototyping. What fuel cells can we get? How much power can we get out of them? How much hydrogen do we need to put into them at any one time? And from that, it informed, kind of in parallel, the design of the system. So you can see in the bottom left, that is a model of the power module, as we call it. That is, it's no coincidence that's in the shape of an engine. The method that we used is to take the truck. Essentially, you take the whole truck apart, you pull the engine out and through the front, and then this would just slide in its place. And of course, other cables and sensors and so on need to go in. But on the bottom right of the four, you can see the final assembly. And then that went on to an actual truck. We got it shipped over on the Antonov and got it running pretty quickly. And this was taken during the presentation for, this one was in the lead up, but yeah, we did a presentation for the President of South Africa. It was a major event for Anglo-American because they're partnering with us because they want to roll this out to their entire fleet, so that their entire mine systems, not just in South Africa, but around the world. And after about a year of operation of that truck, we proved that it was ready to scale. Like we ran it much like the trucks they already had, up the hill, downhill, into the actual mine. It wasn't a proof of concept that was just driving around a track, driving up a hill, dumping some dirt. It was actually working alongside their vehicles on site without impacting them at all. It was as good or even better than some of the truck performance that they had on their current 930s and other 930 or Komatsu vehicles. And a bit of statistics here about how much capacity they can hold and how much of an incline it can go over and how quickly. One of the things we learned from the operators was they wanted to go faster, and that's something that we had to design in. How can we get the truck, if it's stopped on a hill with 300 tons of material, how can it go again? Because it's not as simple as just letting the clutch go. It's a lot of power that needs to go through. And to operate it took over a year. It took much more than just technology. We had to go through operating something on a line, safety, how do we collect data on it, because no one has done this before on this scale. And how does this affect any number of things on the site? It's a system that needs to get, our system needs to go into their system. And we need to figure out how we're going to interoperate with their site, their diesel vehicles, and work together. It's not just about the truck, it's about moving the dirt. The customer wants us to move the material from one place to another. They don't care, well, they do care how it gets there, but really they want it to move, and they want to do it efficiently. So a bit of a peek behind the curtain. We have a site in Australia and in the US working together to build the entire system. I'm actually in that picture in the bottom there, way down there. Right now we're standing up a production facility in Seattle. We call it Sotrace, and it's almost about ready. And it's going to be where we are going to be building the next, I forget the number, it changes all the time, but it's the first few machines that we're going to be selling to customers. And then we just signed a lease on the Proving Grounds in Centralia, which is about an hour south of Seattle. It's a former mine site where they mine coal, and they're in the process of reclaiming it. And we're going to be working alongside the mine operators, which are reclaiming it, to be testing the next prototype in parallel with them, under the same requirements, under the same regulations, under the same safety systems. And, you know, basically it is a mine, and we need to be able to operate in a mine. Bit of a timeline of Firstmode's history. Originally, we were a contract company founded by people from a company called Planetary Resources. Mining asteroids is a lot more difficult than they thought, and they started this company. A lot of smart people from JPL, NASA, did work for NASA and JPL, parts for space satellites, parts for Perseverance. And then we were approached by Anglo American, big mining company, to look at if we could make a hydrogen haul truck, because they were needing a way to offset their carbon or to minimize their carbon output. And it came together and it worked very well, and we're continuing on from there. And it's an investment in the future of energy, and we're trying to find other ways to expand this beyond just trucks. Like, of course, a truck can put into a train, ferries. We have a number of concept projects that we're working on to try to get this into power plant, even for remote power generation. But currently, what we're calling this is the New Gen Aftermarket Kit. Similar payloads today, and we're developing for different trucks as well. Currently, it's just the 930E from Komatsu. We're looking at different sizes, different deployments on different, like Caterpillar and so on. And then with that, I'm going to hand it over for an introduction to Applied CX.
Okay, so Applied CX, we're a platinum partner with Siemens. The X is a variable in our name. We specialize in Team Center PLM, Siemens NX, CAM. The X is more so because we cover CAE for engineering or for manufacturing and for design as well. So we've been working with Siemens for about the past, I think, well, since 2008, so about 14, 15 years. We've partnered a lot with small and medium-sized energy and aerospace companies, and we have a heavy emphasis on the Team Center side. We have a lot of expertise across the board, but that is our primary focus currently.
And getting into how how we did our deployment. And the first thing that, it's a quote that I had from a previous company. I come from a company that made robots that make airplanes. So for Boeing, Airbus, the robots that drill the holes and make the carbon fiber or aluminum wings. And something I noticed there, and also at Firstmode, is we cannot depend on the heroics of our team to make up for the wrong tools. So what we saw in the first deployment, the first build it was a lot of work. And not just work as in turning bolts and making models, it was a lot of work to say, what are we putting on the machine? What does our design look like? What are we buying? What have we bought? And so on. And I drew this next chart for a presentation for our C-suite. These are all the systems we had, where information could be. So you had our NBS, we had our PDM, which was SolidWorks PDM at the time. We had our Wiki, Confluence, our ERP also, and our ECAD, and Excel, of course, everyone uses Excel. And really, all of these places had the truth. So we didn't have a single source of truth that was actually written down. In reality, the source of truth was the collective memory of the company. So if I didn't know where something was, I had to go ask somebody. I had to find the person who knew. I had to find their notes, or we all had to work together as a team, as a collective, to remember things and to know what we did. And as time goes by, that's going to slowly dissipate into the ether of our memories. And you can't depend on that. If we're going to be doing this again, and then making a multi-decade long product that needs to be supported, and we need to produce a lot of them, we can't depend on that. So we need to shift the mind efforts, the thinking efforts of our engineers, of our designers, of our procurement team, to actually making something, rather than trying to remember and retain all of this, and also just search around and see where the information is. So our initial objectives were actually quite simple. So we were working with SolidWorks, and what we found was that it could not handle big assemblies. This is a truck that's as bigger than this room, and with tubes and bolts and all manner of detail that needs to be in it. And we were losing about 2 hours per user per week for crashes, for loading times, for issues with SolidWorks. And SolidWorks is great for smaller things like washing machines and what have you, but when you're coming to trucks, trains, planes, you really can't do it. We also need a single source of truth. We couldn't have everyone trying to remember everything all the time. So we needed a place to store design data in a single place, not multiple places all over the network and the cloud. We needed a way to generate part numbers, because we actually had 2 different part numbering systems that were completely different, and it was painful. And a way to manage them all, because if I have an Excel spreadsheet with my bill of materials and then they're modeling it in SolidWorks, how do I know that my bill of materials for all the electrical stuff matches the SolidWorks one? Well, if it does match, how do I know that I'm not buying the same stuff that they are? I might end up with twice as many connectors, twice as many fuses, and so on. And that's just cost that we shouldn't have to deal with. Another one was having the offices, being able to support offices around the world. So we have our office in Perth and the one in Seattle. And we might even add more in the future in South America or in London. We need to be able to support that and have our team collaborate no matter where they are and no matter what time. And with SolidWorks PDM, it really couldn't do that. And we had different servers, different data repositories in each of those places, and it really didn't lend well to making sure that we're all looking at the same information. Also, since we were a startup, we need a platform that can grow with the company. Like, we don't need everything all at once, where it's just so much for us to be able to handle that we don't have the processes in place, we don't have the number of people that are needed to support it, and we don't have the time. Like, that setting up a PLM is, I knew from experience, because I'd set up 3D experience at a previous company, it takes a lot of time and a lot of effort. And we need to make a product, and we didn't want to focus on that and PLM at the same time. And one of the edicts from the C-suite was avoid third-party integrations at all costs. They had experience at other companies where it was just painful, and I can understand that. What were our obstacles? So, being a startup, we didn't know what business processes we wanted, how we wanted to work, what we wanted to do, how we wanted what we do to work. All of our requirements were constantly evolving. Do we want to have intelligent part numbers? Do we want to have dumb part numbers? How do we want to do releases? What kind of reviews do we want to do? Even our business model changed. While we were working on this, we were actually required by Anglo American and spun off with one of their other companies to better help us to develop these products. So we had a completely different business model change and corporate structure change. And then also, because we needed to build a lot more, we had to hire a lot more people. So there was a huge increase in the number of users. And we had to be able to support that. Having global offices in multiple time zones was also a problem. Making sure everyone felt involved. So you have directors and lead engineers that are down in Perth, they need to be consulted too, and at least give their input into this so that we can get their acceptance as well and get their input, because they have a lot of good advice too. And also just time pressure. We have busy stakeholders, busy engineers, they're trying to start on the next truck. The team that is making the flagship project, they actually wanted NX immediately because they need to model something. That was the key driver for this. So they want NX now, but we also want to set up Team Center, we want to set up everything so that it works as good as possible. We can't have it half set up. And also, unfortunately, our IT staff was really we were understaffed on our IT team, and that was one of the biggest problems we had. So how do we pick Team Center? How do we pick NX? We started by looking at the tools that were available in order to support having large assemblies. So we knew CATIA, they can do it. They model planes, trains, you name it. PTC Creo, also the same. Satellites, planes, you name it. Same with NX, cars. All of them can do it. They're all great. They have their intricacies and their different things that make them unique, but you can 3D model with any of them. They're pretty interchangeable. Then we looked at what our staff knew. A lot of them came from the aerospace industry, so we had a lot of people from Oracle ATK, Northrop Grumman, NASA, JPL, they knew NX. Fewer than I expected on the CATIA side, about 10%. Where I came from, it was all CATIA and SolidWorks, and I knew CATIA. And then Creo, for the people that came from Amazon and some other companies. User sentiments, though, on them was across the board very stark, but there were a lot of strong opinions. So straight away, everyone said anything but SolidWorks. We can't handle it. They were tired of crashing. They were tired of waiting 30 minutes for something to load and then crash. We wanted something better. NX, everyone liked it. No one said anything bad about it. Creo was, this is actually a direct quote, not bad, not good, it was good, but not bad. Also, we had feedback already, so worse with NX, probably would want to stick with something that we are using. And then, from my experience with 3D Experience, it isn't quite ready. I was tired of trying to fight with it and get it working. We used it at my previous company. It was a lot of work. It didn't do quite what we needed. It was still being developed by us, so it's good, but by evaluating it and looking at Team Center, we found that Team Center would probably be the better option. So why did we go with Siemens? We use FEMAT, we were familiar with it. We saw before, more employees were familiar with it. Employees had more experience with the other ones. Also, it had a very extensive portfolio. Like, this is a picture that was from Applied CAX. Doesn't really come through here. But this is just a small part of a larger kind of like high-level view of the portfolio from Siemens, and we were just picking bits and pieces out of there that we needed today and maybe for very soon. But they had everything we needed. And we can add things later as well. So we have the basics, PLM foundation, we have some of the other tools in there, and we can add other things as we go. Like it slots in, it's very modular, it's very configurable. And also Siemens is a big company, they'll be around for a very long time, so we don't have to worry about them disappearing from the market. So we picked our product, we picked our system. How did it go? So we started in mid-June. There was a bit of planning that went up to it about working with Applied on how we want to approach it, what we need to do before we get started. And while we were doing that, we were also trying to define our business processes, which was very appreciative of Applied CAX's patience, because we were asking them a lot of questions on how do other companies do this, and how do they manage change, how do they manage releases, how do they work? And in this very short amount of time, in less than 3 months, we had the servers running. We were in production. People were actually using NX and storing at Team Center. And comparing that to other deployments I've seen, that was fast, really fast. And I went really well in that respect. Here's just a picture of I took this from a presentation I did for our C-suite as a kind of a status update of the steps that we went through. Pretty generic, evaluating the 3D CAD, finding the ECADs that we wanted to go through, and then on the right is the phase one of getting our server stood up, installing the PLM, figuring out what kind of partners we want to use, testing on users, and then being ready for the deployment and dealing with users. Oh, we will jump in.
Yeah, and just to add here, so we see this a lot with new startups. A lot of the times they don't really have their processes worked out, or they're still trying to kind of figure out how things are going to work internally. When we first started with Firstmode, we were still in the early stages of our new package that we're now selling called Basic Essentials. Basically what we're trying to do is take a lot of that initial conversation that maybe takes 2 months to kind of work through some of these, what is a workflow, how does your process flow, and we come up with some initial recommendations to streamline that for you so that we alleviate a lot of that time investment, that time sink that comes with a Team Center or a PLM implementation. We also have similar things on the NX side as well to help with that. So we're really trying to drive to help reduce the implementation time, because we see a lot of companies going through multi-year implementations because maybe they're trying to build the entire bridge to start with, and that's not always where you want to necessarily start. You want to grow into it. So we're definitely focused heavily on trying to reduce the timeline to make sure people are in there and using the system, because it's easier to adopt later modules and do what you really want to do.
And then while we were doing a lot of the setup, as we were approaching the final deployment, we wanted to have our users ready to go right when we turn the servers on to be ready to start modeling in NX. So we had 30% users do not use NX, but that leaves another 70% who don't. So we had to get them trained up. So we set up concurrently while we were working on this to have Applied CX schedule the trainings for the US. We had 3 week-long sessions on NX basics for new users and users who've used it before. And then one in Australia that they actually flew out to Australia for. It was amazing. And then we also, for a lot of our users, were familiar a little bit with SimCenter, but we needed additional training, one in the US and one in Australia, just to get us up to speed even more quickly and save that time. And I had a graph here of where the trainings are. It's not really coming through in the lighting, but there's a lot of concurrency in this, of things happening at the same time that just seem to work out. So what went well? Forming a team at the company that is dedicated to working on the PLM. Like we were calling it the PLM. I called it Project Tesseract because it sounded cool. Important was it it was dedicated. It put its time into working on this, finding the stakeholders, answering the question, getting questions from people, and then bringing it to applied CDX, or just what business processes you wanted, because someone needed to move things along and carry this to the end. Also, what worked is having a phased and minimum viable product approach. You can't do everything at once. You can try, and it will maybe work. It's a lot though. Like a PLM is not something that's simple to implement. And if you have all the processes in place, maybe you can. And if you have the personnel and importantly the time, it's a lot to ask. So for us, for a small startup, we just needed to make models, store them, release manage, and revision manage. And we got it. It worked. And we can still layer on top of that with a modular setup of Team Center, but we can work now, and we can work with the tools we need now rather than later. Another one was focusing on configuration and not customization. So customization adds a lot more risk, in my opinion, to if depending on this program to work day in, day out, after upgrades, and so on. If you're customizing it, you're making changes to the system. And if that fails, and if you go to Siemens or so on, you say, oh, this is broken, and they're like, did you customize it? And you said yes, and I'm like, well, did you check the customization? So it can get difficult to support, and you have to have the people to support it, which we didn't really have the time. And also, it's faster just to configure it, use it as it is, more or less out of the box, and configure it to what you need rather than force this very intricate program to do what you need. Much safer, much easier, much faster. Another thing that worked really well is going with what I call dumb part numbers or non-encoded part numbers. This was probably the most contentious thing of the whole thing. No one could agree on it. We went back and forth on it a lot, and where we ended up was, how easy is it for users to use? So are they spending their time trying to figure out, where's my part on the assembly? Do I need to give it a special number because of that? Oh, I moved it. Do I need to give it a new part number? Do I need to make a new thing? There's a lot of thinking and a lot of effort that would go into that. And with quote unquote dumb part numbers, you don't have to think. You click assign, you get a part number, you start working. Done. It also allows you to take advantage of something that Team Center does really well, which is attributes and metadata. You can have whatever you need on the item as metadata, and that allows you to edit the metadata and read the metadata rather than having an encoded part number, which might have these 6 digits mean this and these means that. But then if you have something else, it changes it. It's a lot of effort for something that maybe not a lot of users would use. But it was controversial, it's still controversial. It went all the way up to the C-suite for how to decide it, and most users are behind it, I will say, and I think people are coming around to it, but there's still some holdouts. Another thing that worked, and I'm actually really glad that Applied CDX recommended this, is to go with cloud hosting on Amazon EC2. It just works. Like, there's a little bit of support that goes behind it, but we're not dealing with servers. I remember we had our licensed server in the US go down because of a power outage, and the UPSs didn't work, and NX wasn't working. I had to drive into the office really quickly and run up the stairs and try to find our server on the rack and unplug it and plug it back in, and that was a lot of exercise. It was a lot of running. Another thing that helped a lot is negotiating flexibility around license terms. We worked with Applied CDX on how we can try the different licenses and get to know the software, the platform, what it can do, to see okay, is this something that we can use? We don't really know it too well. We're building processes, and it's been invaluable in order to say, we need to try this. Can we get a demo of it? And we just get it immediately, and we're able to make a decision much more quickly and get our hands on the tool. And the engineers especially like that part. Also, huge asset in doing this. They have a lot of experience doing this. They're on schedule all the time, and it was actually nice to have them be very honest and authentic with the communication and past experiences. Like with our previous implementer at my previous company, it was they would just give us what we wanted. It was nice to push back, get honest opinions, people who have seen this. Open communication. They even joined our Slack channel, or our Slack server, so we could communicate very quickly. That was extremely valuable when something would go down during the implementation. And also just very patient. Like, it was really nice to not be rushed. They might even know that we're making a bad decision. They would talk us through it. We would work through it and discover, yeah, it's probably not the right decision. And flexible hours, flexible communication methods. It was very easy to work with them. User training too, we had those 3 weeks and then the 1 week in Australia for NX. Across the board, everyone loved it. Shout out to Steve. It was really, really good NX training. All of our users liked it. Even gave us a bunch of copies of his book so we can reference it later, give it to new hires. They even traveled to Perth for training, which I think was also a nice vacation for him. But it was awesome support. And even in our after sales support, very easy to talk to them, work through the ticket system, very responsive. We still are having configuration issues and user learning errors. Being able to get a quick turnaround on how do we put out this fire, or is it's not actually a fire, it's just a user error, here's how we do it better. Invaluable when people are time crunched. To go into a bit of what didn't go well, implementing an ERP and a PLM at the same time. I heard that described as doing brain surgery and heart surgery at the same time. It is a lot. And we went with a company called Plex, and we were implementing and figuring out business processes and how that's going to work and configuring it, and also figuring out how they're going to work together. Don't do it. It really is a lot of work. If you have to, be very pace yourself. Figure out the best way to do it. Make sure you're communicating with the team that's doing the ERP. That is critical, is communication between the two teams, because it's very easy for them to get siloed off and feel like, okay, we're procurement and manufacturing, they're the designers, we have this nice wall of protection. No, you can't do that. They have to be interconnected in some way to communicate. The other thing was figuring out requirements as we go. Figuring out the processes. It's a lot. It's also a lot of work trying to get agreement, get all the stakeholders in one place to decide something, especially when they're in different time zones. It's not something that you can do very quickly, and getting agreement is probably the hardest thing in doing this when you're doing business processes. And that brings to the next one is, who's the decider? Who's making the final decision on things? Who says, okay, this is the process we're using. All of these are good, and all of these will work. Which one do we pick? You have to pick in the end. You can't have a smart and dumb partners. You have to pick one thing. And I was the lead of the implementation team, but I wasn't the one who was the decider. That was directors and the C-suite above me, and it really helped having someone who was the champion kind of above that to make sure things keep moving along. So have a decider, make sure they're involved, keep them involved, communicate with them, tell them about problems. It's critical. Another one is user testing. You really need to test things and get users, not so much to see if it breaks, not to see if it's working, but to get a feel for what they think of the program. How are they using it? Where are they getting stuck? What don't they like? What do they like? How can we make this better? I can think of a case where we came up with this nice way of releasing things. it was causing a lot of problems for users, and they were getting confused about when to assign reviewers and so on. Once we had them tested and sat down with them and went through it, we were able to find out what was causing the issue, make it a bit smoother. This one kind of comes back to implementation is, how is it supposed to work? How is NX supposed to work? What did the developers intend for this function to do? What did the Team Center developers intend for this to do? Are we using it correctly, or are we using it in a way that's going to be painful in the future when we want to implement something else, like change management or what have you? And this is where Applied CX really helped us out in saying, okay, you could do that, but you're going to be dealing with all these other things in the future. So we were very lucky to have a very experienced team helping us in Applied. And the one thing that will probably never be something that you do is to make everyone happy. You can't. And eventually, this is where the decider comes in. You have to make a decision. And we tried to make everyone happy. We tried to make the system as smooth as possible. We tried to hit all the dreams and desires of the teams. You can't. And you can make sure the product works and works well, but I try to make everyone happy, and it is very difficult to do and to say no sometimes, but you do sometimes you do it to say no, you get to say later or what have you, but you have to do your best. So where are we currently? We are using Siemens NX. We're designing parts and assemblies, we're doing harness routing, multi-team, multi-continent. We have like 4 different teams in the US working on the different subsystems of the truck. They're all working together. They're able to collaborate within the same system, which is awesome. We're using token-based applications. It's just much more flexible for us. We're able to check out software and basically anything from the NX portfolio, I think, as we need it. Hugely beneficial as users are trying to figure out what tools do they need and how they can work most effectively. We're currently mostly using NX structure design, advanced assemblies, and the NX routing tools. Still figuring out the NX routing tools a bit. We didn't have anyone experienced with it, so we do now, and they're doing a pretty good job. And also we have a machinery library, which is for our fasteners. Make sure that everyone's using the same set, all metric, all the same models, really nice, fully featured, very consistent models that were produced using the part family functionality. And then on the Sim Center side, we're doing a lot of structure analysis on these big system, big heavy structures, doing static and modal analyses. I'm an electrical engineer, I don't actually know what those mean. And I'm currently working on, I'm working on simulating electrical bus bar sizing. So we have thousands of amps running through some of these cotton bars, and I can do the math, I can do a lot of it in Excel or on a notepad, but having that check and having the ability to easily simulate how much a couple hundred amps or 1,000 amps going through a chunk of copper, what is that going to look like for heat, and what are we going to, is my simpler calculation matching up with what the bigger program is doing. And this one was done with, I think, Flow, which is a tool in SimCenter. Much easier to use. I've never done meshing, and using this is much easier. In Team Center, we're using Active Workspace. We're using the direct integration with NX straight in for storing. We're also doing some manual storage of PCBAs from Altium. We didn't get to finding a way to integrate Altium directly in, so we're just doing it manually for now. We also use AutoCAD Electrical for drawing the harnesses. And there's actually supposed to be a lot of text there showing the bill of materials. That looks really cool, but it's not showing up there. But trust me, there's a lot of text there for the bill of materials. We're storing our simulations manually as well. We're not using the direct integration with SimCenter yet. Document storage, revision control, and the usual release workflows. One of the things that's been very popular, I wasn't expecting it, is the browser-based 3D visualization that's shown here. If you don't have to open NX to look at something and spin the model, it's really helpful when you're talking to stakeholders and managers who might not necessarily be very familiar with using NX, or if you're just doing a quick presentation, you're able to spin this model and show it off. It's been very popular across the company. And on the back end, we're using Amazon Web Services, EC2. All of our servers now are on there. Originally we had the license server as a physical server. Now we have it in the cloud as well, and we have one in Australia. It's not a cache server. What was the term for it?
Remote volume.
A remote volume in Australia. And then there's a total of about 12 Team Center servers.
Well, there's 12 production servers. We do have a test environment as well as a development environment as well.
Right, and the test environment is a mirror copy of the production one, so we can just do full-size testing, which has been totally valuable. We also have centralized user defaults that are just stored in a central server that users can get from a remote directory. That's been pretty nice to make sure everyone's using the same settings. And another benefit is we're able to use CloudWatch, which is a monitoring tool system within Amazon. So we can put in whether the servers are running, what services on them are running, how's our license usage, and any other metrics that we can get out of servers. And also, we're currently working on, I think we've even just deployed a custom link between Team Center and Flex on what Jesse said.
Yeah, so we ended up initially talking about T4EA as a solution. And we've had many discussions internally with Firstmode about that. One of the biggest initial issues and reasons why we didn't move forward with that was just implementation time for the setup, the initial cost of that setup. It's a large obstacle, especially as you just start with your ERP system, which we see a lot of the times you're just coming in, so you're still working through your ERP process too. So a lot of the times the investment for T4EA is not yet there as far as what you get back from that investment. So what we came up with was a solution to bridge the gap as an interim solution, and then long-term move more into that T4EA product. And that product is what Applied and Firstmode worked on and is now called the DICE product.
And a bit more on the CloudWatch monitoring, really quick. It's a way to take, there's like a CLI program for within Windows to see what licenses are being used. And, it's only a snapshot in time though. You're able to, I wrote a script and some clever usage of CloudWatch to send that information into CloudWatch so I can see it over time, max mins, how many do we have total. It's a huge time saver and it's way easier than you think. It's very easy to do. Lessons learned, get buy-in from leadership, that's the big one. Have a leader, have someone who can make decision authority. Definitely involve IT early, make sure that they're informed and helping you set up any servers that you need, or with Amazon, or even just local for testing, or getting people computers they need. Definitely communicate with users and go slow. Change is, something that's difficult for people, especially if they're trying to work on something and you're changing it under them. And acceptance is very easy to lose. Like if you lose that, it's very difficult to get users to come back sometimes. And you want to bring in those silos of different teams in almost one at a time, so that you're only changing the hearts and minds of one team. And by changing it in one, it's easier to change it in others. So as word spreads and efficiency is noticed, you're seeing the benefits. It's easier for other teams to move in when they see the benefit of it. Also, as we mentioned before, having a full test environment is totally worth it. It seems like a lot of extra servers. It's worth doing. Having a full-size test, having that to test on is extremely valuable and worth the effort and time. And also cloud hosting, definitely worth it. Do it. It's much better than dealing with hardware and downtime. So what's next? We want to implement engineering change notices, problem reports and so on. Configuration management, how are we going to have the high altitude version of a truck and the normal one, or different options, or just effectivity, dealing with that. We're not dealing with it yet. We want to implement M-bombs. That's something that's new that we want to look at as we're going to be getting into a more production-oriented mindset. We're talking about requirements management and how to do component level metadata, and working together at the system level in BSC. And of course, we're going to want to upgrade to the latest. After coming to the Realize Live and seeing all the new features that are coming out, we're definitely going to want to upgrade to the latest ones pretty soon. And one of the things that we're talking about is cryogenic gas simulations with Star CCM. That's something that's a little further down, but looking forward to. I'm going to try to go quickly through these. Things are still figuring out. Getting ECAD. We started with mechanical. We're probably going to spread over to the electrical department soon. We looked at ELD. Wasn't a good fit. Great team though. Definitely like them. Capital didn't have the depth of the integration we were looking at with NX, but we're seeing it. Now that I've been here and seeing it, I was misunderstanding it, so it is there, and I think that we could make use of it. And then component level data and how we can manage that in NX, so reference designators, reliability data, and so on. How can we get that information that's showing on both capital and NX and Team Center? Then also working on NX routing. How can we do the model history? Keep track of the time. Over time, how the model's changing to be able to roll back. And then how do we document design for reliability? How do we keep track of that information of mean time to failure and so on? How do we include that in our information that's going into our build materials? And with that, I'd like to open up for questions a little over time. I'll be over at the Applied CDX booth for the next hours or so, and happy to answer any questions there too.